Welcome to the deep dive. Where we like to take these complex topics and try to break them down and make them a little bit easier to
A
understand.
little more digestible.
Yeah, exactly. And today we're going to be diving into the world of asynchronous messaging in software design.
Oh, very cool.
It's a pretty fascinating topic, and it's actually something that's it's kind of a cornerstone of modern software development, especially when we're talking about building systems that need to be really scalable and resilient.
Yeah, and I think people run into it all the time, and they don't even necessarily know what it is.
Right, exactly. It's one of those things that's kind of happening behind the scenes, and it's really making a lot of the things that we use every day possible.
Right.
And so our guide for this deep dive is a blog post that I found called Challenges of Asynchronous Messaging in Software Design.
Okay.
And it was published just a few days ago, actually, on December 4th, 2024, on the Continuous Improvement blog.
It's a pretty recent.
Very recent. So it's a hot topic right now. And I really like that this post really kind of highlights not only the benefits of asynchronous messaging, but also, the challenges and complexities that come with it.
The things you got to watch out for.
Yeah, exactly. So it's not all sunshine roses, right?
Right.
So one of the things that the post talks about right at the beginning is this kind of mental shift that developers need to make when they're moving from a synchronous to an asynchronous world.
Yeah, that's huge.
Can you talk a little bit about that? What is that like?
Sure. So it's a really fundamental change in how you think about communication between different parts of a system.
Okay.
In a synchronous world, it's kind of like you said, sunshine and roses. It's like making a direct phone call. Like you dial a number,
Right.
Somebody picks up on the other end, you get your answer immediately.
Yeah, response.
Yeah. But in an asynchronous world, it's more like sending a letter.
Oh, okay.
You write it, you put a stamp on it, you put it in the mailbox.
Right.
You send it off, and then you kind of wait.
You have to wait.
Yeah. And you don't know when or if they'll respond.
Right, or how long it will take.
Yeah, exactly.
Oh, interesting. So it's not this like immediate back and forth. It's more like you're sending a message out into the void,
Right.
and then you're just trusting that it's going to get where it needs to go.
Yeah. And you're trusting that the system is designed in such a way that it can handle that.
Right. Okay. So instead of waiting for that immediate response, you're basically sending these messages into the system and then carrying on with other tasks.
That's right. And that can be a real challenge for developers who are used to thinking in a synchronous way.
Right. Because you have to kind of like let go of that control a little bit.
You do, and you have to really think about how you're going to design your system to handle these messages that are coming in at unpredictable times and in unpredictable orders.
Okay, so that actually brings up one of the other challenges that this post talks about is this idea of messages arriving out of order.
Yeah, that's a big one.
So how do you even like approach that? Like how do you prevent that from happening?
Well, you can't always prevent it from happening.
Okay.
Because in a distributed system, things are happening in parallel, and messages can get delayed for all sorts of reasons.
Right. Network issues, server issues, all that.
Exactly. So you have to design your system to be resilient to that.
Yeah.
And to be able to handle messages that arrive out of order.
Okay, so that's where things like correlation IDs and structured logging come in.
Exactly. So a correlation ID is like a unique tracking number that you attach to each message.
Okay.
And then you can use that to follow the message's journey through the system and to make sure that it gets processed in the right order, even if it arrives out of order.
So it's like a little breadcrumb trail.
Yeah, exactly. It says a little breadcrumb trail.
That you can follow.
Yeah. And then structured logging is basically a way of making sure that all of your log messages are formatted in a consistent and machine-readable way.
Okay.
So that you can easily search and analyze them and figure out what's going on in your system.
So you can see the flow of these messages and where they're going and how they're being processed.
Exactly. And that's really important when you're dealing with asynchronous systems because things can get really complicated really quickly.
Yeah, it sounds like it could get very messy.
It can.
Very quickly.
Yeah.
So, I mean, especially when you're dealing with, sensitive operations like financial transactions or, things where the order of operations really, really matters.
Right. And that's why it's so important to have good monitoring and debugging tools in place so that you can catch these problems early on and fix them before they cause any serious damage.
Yeah, it sounds like it's all about having the right tools to kind of monitor and manage this web of messages that's going back and forth.
It is, and it's about having the right mindset.
Yeah.
You have to really think differently about how you're designing your systems when you're working with asynchronous messaging.
So that mental shift is really key.
Yeah, it's really key.
Okay, so let's talk a little bit more about this challenge of messages arriving out of order. what are some of the specific techniques that developers use to prevent this asynchronous chaos from wreaking havoc?
Well, one common technique is to include sequence numbers in the messages.
Okay.
So you're basically numbering the messages as you send them.
Right.
And then the receiver can use those sequence numbers to put the messages back in the right order, even if they arrive out of order.
So it's like numbering the pages in a book.
Exactly. It's exactly like numbering the pages in a book.
Even if they get shuffled up, you can still put them back in the right order.
Right. And then another technique is idempotent processing.
Okay, I've heard of that. What is that again?
So idempotent processing basically means that you can process the same message multiple times, and it will only have the intended effect once.
Oh, interesting.
So, for example, if you're processing a payment,
Right.
you don't want to accidentally charge the customer twice
No.
if the message gets processed twice.
Right. You want to make sure it only happens that one time.
Right. So you would make sure that your payment processing logic is idempotent, so that even if the message gets processed multiple times, it only actually charges the customer once.
So it's kind of like hitting the elevator button multiple times.
Yeah, exactly.
It's only going to go to that floor once.
Exactly. It's only going to go to that floor
No
once.
matter how many times you press the button.
Right.
Okay, so that's a good way to kind of like build in some redundancy and some safety into the system.
Yep.
Okay. And then for situations where the order of messages is absolutely critical, like, we were talking about financial transactions.
Right.
Developers often turn to specialized message brokers like Kafka.
Right.
Can you talk a little bit about Kafka and why it's so popular in this context?
Sure. So Kafka is a really powerful message broker that's designed to handle high volumes of streaming data.
Okay.
And one of the key features of Kafka is that it guarantees the order of messages within a partition.
Okay, what's a partition?
So a partition is basically a way of dividing up the messages in a Kafka topic.
Okay.
So you can think of a topic as like a category of messages.
Right.
And then a partition is like a subcategory.
Oh.
And within a partition, Kafka guarantees that the messages will be delivered in the exact order that they were sent.
Ah, so it's like having these designated lanes
Exactly.
for these messages to travel in.
Exactly.
And so within that lane, the order is preserved.
The order is preserved, yes.
But between lanes, it's not necessarily.
Right. It's not necessarily guaranteed between partitions, but within a partition it is.
Okay, that makes sense.
Yeah,
So it's bringing order to the chaos, at least within those designated lanes.
exactly.
Okay. So we've been talking a lot about like the truly asynchronous world.
Right.
Where you're sending these messages out and you're not really expecting an immediate response.
Right.
What about situations where you actually do need immediate results?
Right.
Like not everything can be like sending a letter and waiting for a response.
Right.
What do you do in those cases?
Well, in those cases, you can use a hybrid approach
Okay.
where you combine synchronous and asynchronous messaging.
So you're kind of blending the two worlds. Exactly.
You're blending the two worlds, and you're using the best of both worlds.
Okay.
So, for example, you might use synchronous messaging for the initial request,
Okay.
and then use asynchronous messaging for the processing that happens in the background.
Okay. So it's like you're sending the request and you're getting like an acknowledgement
Right.
immediately, but then the actual work is happening asynchronously behind the scenes.
Exactly.
Got it.
And then when the processing is finished, you can send a notification back to the client using synchronous messaging
Okay.
so that the client knows that the operation is complete.
So it's kind of like you're getting that immediate feedback,
Right.
but you're not blocking the system.
Exactly. You're not blocking the system.
Okay, so what are some of the ways that developers actually do this? Like what are some of the techniques that they use to blend these two worlds?
So one common technique is the request-reply pattern.
Okay.
So in the request-reply pattern, the client sends a request
Right.
and then waits for a reply. But the processing of the request can happen asynchronously in the background.
Okay.
So the client doesn't have to wait for the processing to finish before it gets a response.
Right.
And then another technique is caching.
Oh, yeah.
So caching is basically a way of storing frequently accessed data in memory
Okay.
so that you can retrieve it quickly.
So you don't have to go all the way back to the database every time.
Right.
You can just grab it from the cache.
Right. And then another technique is timeout management.
Right.
So timeout management is basically a way of making sure that if a request takes too long to process,
Okay.
you don't just wait forever.
Right.
You set a timeout. And then if the request doesn't finish processing within that timeout, you do something else.
You abort it or you retry it or something like that.
Exactly.
Okay, so these are all kind of ways of like making sure that the system is responsive,
Right.
even though you're doing some of this processing asynchronously.
Exactly.
Okay, cool.
Yeah.
So we've talked about a lot of the benefits of asynchronous messaging, but it's important to remember that it's not a silver bullet,
Right.
right? It comes with its own set of challenges and trade-offs.
It does.
And one of the big ones is performance,
Yes.
right? So asynchronous messaging can actually introduce some performance overhead.
It can.
Can you talk a little bit about that?
Sure. So one of the main sources of overhead is serialization and deserialization.
Okay.
So when you're sending a message over the network, you have to convert it into a format that can be transmitted over the wire.
Right.
And then when the message is received on the other end, you have to convert it back into its original format.
So you're basically like packaging it up and then unpacking it
Exactly.
on the other side.
And that process of packaging and unpacking can take some time.
Right. It takes some processing power.
It does.
Okay.
And then another source of overhead is network latency. So it takes time for a message to travel over the network.
Right.
And that latency can add up, especially if you're sending a lot of messages.
Especially if you're going across like, different data centers or something like that.
Exactly. Or even if you're just going across the room.
Right.
It still takes some time for the message to get there.
Okay.
And then finally, there's the overhead of event handling.
Okay.
So when a message is received on the other end,
Right.
you have to have some code that's going to process that message.
Right.
And that code can take some time to execute.
So there's all these different steps that are involved in asynchronous messaging.
Right.
And each of those steps can add a little bit of overhead.
It can.
Okay.
And so it's important to be aware of that overhead
Mm.
and to design your systems in a way that minimizes it.
So it's not just like a free lunch.
Right.
Like there are some costs associated with it.
There are.
Okay. And then another big challenge with asynchronous messaging is dealing with databases,
Yes.
right? So a lot of applications rely on databases to store their data.
Right.
And when you're using asynchronous messaging, you can run into some problems with database contention. Can you talk a little bit about that?
Sure. So database contention basically happens when you have multiple applications that are all trying to access the same database at the same time.
Okay.
And that can lead to performance problems
Right.
because the database can only handle so many requests at once.
It's like a bottleneck.
Exactly. It's like a bottleneck.
Okay, and this can be especially problematic in asynchronous systems
You can.
because you often have multiple processes or threads that are all working in parallel,
Right.
and they're all trying to access the database.
Right.
So how do you prevent this database mayhem?
Well, there are a few different techniques that you can use.
Okay.
One technique is data partitioning.
Okay.
So data partitioning is basically a way of dividing up your database into smaller pieces.
Okay.
And then you can store those pieces on different servers.
Okay.
And that way you can reduce the contention on any one server.
So you're kind of like spreading the load.
Exactly.
Yeah.
Spreading the load.
Okay.
And then another technique is event sourcing.
Oh, yeah, we talked about that earlier with the messages themselves.
Right.
How does that work with the database?
So event sourcing is basically a way of storing your data as a series of events
Okay.
rather than storing the current state of the data.
Okay.
So for example, if you're building a bank account application,
Right.
instead of storing the current balance of the account,
Oh.
you would store every deposit and withdrawal that's ever been made to the account.
Oh, interesting.
And then you can use those events to reconstruct the current balance at any time.
So you're basically storing the history of all the changes
Exactly.
rather than the final result.
Right.
Okay, that's a very different way of thinking about data.
It is.
Okay.
But it can be really powerful.
Yeah, I can see how that would be useful in some cases.
Yeah.
Okay. And then another technique is using read replicas.
Right.
So read replicas are basically copies of your database
Okay.
that are used for read-only operations.
So if you have a lot of read traffic, you can use read replicas to offload that traffic from your main database.
Right.
And that can help to improve performance.
So you're basically like creating multiple copies of your database.
Right.
And then you're directing the read traffic to those copies so
Mhm.
that the main database can focus on the right traffic.
Exactly.
That makes sense.
Yeah.
So these are all kind of like advanced techniques that developers can use to manage these database challenges in an asynchronous world.
Right.
It sounds like it's a whole other level of complexity
It is.
to think about,
Yeah.
but it's necessary.
It is if you want to build high-performance asynchronous systems.
Right. Okay, so we're going to take a break right now.
Okay.
And when we come back, we're going to talk a little bit more about some of the other challenges of asynchronous messaging
Sounds good.
and how developers can overcome them.
All right.
So stay tuned.
We'll be right back.
So we were talking about this idea of database mayhem when you've got all these messages flying around in an asynchronous system.
Yeah, it's a real concern. You've got all these different parts of the system trying to read and write to the database at the same time. And it can cause all sorts of problems.
Right, like bottlenecks and inconsistencies and even those dreaded deadlocks we were talking about.
Exactly, where everything just grinds to a halt.
Yeah, not good.
Not good at all.
So, what are some of the techniques that developers use to prevent these data disasters from happening?
Well, one common approach is data partitioning. It's like dividing a big city into smaller neighborhoods.
Okay.
Each neighborhood has its own little shops and services, and people can go about their business without having to travel across the whole city all the time.
So instead of having one massive database, you're splitting it up into smaller chunks.
Exactly. And each chunk can be stored on a separate server, so you're distributing the load and reducing the contention.
So it's like creating dedicated lanes on a highway to keep traffic flowing smoothly.
Precisely. Each application can work with its designated portion of the data without interfering with others.
Makes sense. What other strategies do developers have in their arsenal for tackling these database challenges?
Well, another fascinating technique is event sourcing.
Event sourcing. Okay.
This one's a bit more conceptual, so bear with me.
Okay, I'm ready.
Instead of directly updating the database with each change, you record every change as an event in a log. It's like having a detailed journal of every action taken.
So it's like a version control system for your database. You can always go back and see exactly how the data reached its current state.
That's a great analogy.
Yeah.
Event sourcing gives you this incredible audit trail, and it makes it much easier to rebuild a system or roll back to a previous state if you need to.
That's pretty powerful, especially for systems where data integrity is super important.
Absolutely, and you can even derive different views of the data based on the sequence of events, which can be very useful for analytics and reporting.
So you're not just storing the current snapshot, you're storing the entire history of how you got there.
Exactly. And that can be incredibly valuable for understanding how the system behaves over time.
It sounds like event sourcing has a lot of advantages, but I imagine it also has some complexities.
You're right, it's not a silver bullet. It does require a different way of thinking about data and transactions.
Right, it's not just a simple update anymore. You're appending to this log of events.
Exactly, and you need to think carefully about what constitutes an event, how to handle event versioning, and how to store and query this ever-growing log of events.
So it's a powerful tool, but it's not a magic solution. You need to use it wisely.
Absolutely. It's all about choosing the right tool for the job.
Now, you mentioned read replicas earlier. How do they fit into this asynchronous database puzzle?
Yes, read replicas. They're like having backup singers for your main vocalist.
Okay, I like that analogy.
They handle the read operations, while the primary database focuses on the heavy lifting, the write operations.
So it's like having multiple copies of a popular book in a library. More people can read it simultaneously without having to wait in line.
Exactly. By offloading the read traffic to these replicas, you reduce the load on the primary database, and everyone wins.
The system is more responsive, users are happier, everyone's dancing to the same tune.
Exactly. It's all about harmony and balance.
So we've talked about managing message order and handling performance considerations. And now these complex database challenges, it sounds like developers have a lot to juggle when it comes to asynchronous messaging.
They do. It's a multifaceted discipline that requires a deep understanding of distributed systems and a willingness to embrace a new way of thinking.
It's like learning a new language or a new way of thinking about how systems interact.
Precisely. It's a shift in mindset from sequential step-by-step execution to event-driven architecture.
So what are some of the key things developers need to learn to thrive in this asynchronous world?
Well, first and foremost, they need to embrace the idea of letting go.
Letting go.
Yes, letting go of the need for immediate control and certainty.
So it's about becoming comfortable with a certain level of uncertainty and unpredictability.
It's exactly. In an asynchronous world, things don't always happen in a predictable order or on a predictable timeline. You have to be okay with that.
Okay, so that's the mindset shift. What about the technical skills? What do developers need to know to build these asynchronous systems?
Well, luckily, there are some well-established design patterns that can help guide them patterns, like publish-subscribe, where senders can broadcast messages to multiple receivers without needing to know who those receivers are.
That sounds familiar. It's like a radio station broadcasting a signal, and anyone with a receiver tuned to the right frequency can listen in.
Precisely. It's a very powerful and flexible pattern for building loosely coupled systems.
Okay, what other patterns are out there?
Well, another popular one is CQRS, which stands for Command Query Responsibility Segregation.
Command Query Responsibility Segregation? That's a mouthful.
It is, but it's a very important concept. It basically separates the logic for handling commands, which are actions that modify data, from queries, which are requests for information.
So it's like having different departments specialized in handling different types of requests. The command handlers are the action takers, while the query handlers are the information providers.
Exactly. And this separation allows you to optimize each path independently, leading to greater efficiency and scalability.
Okay, so publish, subscribe for broadcasting messages, CQRS for separating commands and queries. What else is in this asynchronous toolbox?
Well, then there's the saga pattern, which is particularly useful for managing complex transactions that span multiple services.
Saga pattern. That sounds intriguing. Tell me more.
Imagine booking a trip online. You need to reserve flights,
Mm.
hotels, maybe even a rental car. Each of these actions might involve different services or systems.
Right, it's a whole chain of events.
Exactly. And the saga pattern helps you orchestrate these distributed transactions by breaking them down into smaller steps and defining compensating actions in case something goes wrong.
So it's like a well-coordinated dance with backup dancers ready to step in if someone trips.
Exactly. You've got a plan A and a plan B, and maybe even a plan C, to ensure that even if something unexpected happens, the overall transaction completes successfully.
No more booking nightmares where your flight's confirmed, but your hotel reservation vanishes into thin air.
Precisely. The saga pattern brings order and reliability to these complex asynchronous workflows.
It's amazing how developers have figured out ways to tame the complexities of asynchronous messaging and use it to build these incredibly powerful and resilient systems.
It's a testament to the ingenuity and creativity of the software development community, and it's constantly evolving as we face new challenges and discover new possibilities.
And it's not just about the developers themselves, right? There are also these supportive frameworks and libraries that help make their lives a bit easier.
Absolutely. These frameworks and libraries provide pre-built components and utilities that simplify common tasks and abstract away a lot of the low-level details.
Ah, yes, those helpful assistants that make developers' lives a bit easier. What role do they play in this asynchronous world?
Well, they're like having a toolbox filled with specialized gadgets and power tools, ready to tackle any asynchronous challenge. They provide pre-built components for message serialization, routing error, handling all sorts of things.
So it's like having a team of skilled assistants taking care of the tedious, repetitive tasks, freeing you up to focus on the bigger picture, the overall design and architecture of the system.
Precisely, these frameworks and libraries can greatly accelerate the development process and help ensure that asynchronous systems are built correctly and efficiently.
Okay, we've covered a lot of ground today. Can we take a moment to recap the key takeaways from our deep dive into asynchronous messaging? What are the essential things listeners should remember?
Absolutely. We started by talking about the fundamental shift in thinking required when moving from a synchronous to an asynchronous world, letting go of that need for immediate responses, and embracing the idea of events and reactions.
It's like learning to trust that the message will be delivered and acted upon even if it doesn't happen instantaneously.
Exactly. We then explore the challenges of tracking those messages and ensuring they're processed in the correct order, using tools like correlation IDs and structured logging to maintain order amidst the potential chaos.
It's like having a reliable postal service with tracking numbers and delivery confirmations, ensuring those important messages reach their destination safely.
We also delved into the performance considerations of asynchronous messaging, recognizing that while it offers advantages in terms of scalability and responsiveness, it also introduces overhead costs.
It's like understanding that while sending individual letters might seem inefficient, sometimes it's the best way to ensure personalized delivery, while other times batching those letters into a bulk package makes more sense.
And of course, we can't forget those database dilemmas. We discussed how to prevent data bottlenecks and deadlocks in an asynchronous world, using techniques like data partitioning, event sourcing, and read replicas to keep those systems humming along smoothly.
It's like having a well-organized library with multiple copies of popular books and efficient systems for handling checkouts and returns, ensuring everyone has access to the information they need without causing a traffic jam.
And finally, we highlighted the importance of training mentorship and embracing design patterns like publish, subscribe, CQRS, and Saga, those guiding principles and best practices that help developers navigate this complex landscape.
It's like having a team of experienced architects and engineers guiding you through the construction of a magnificent asynchronous skyscraper, ensuring it's built to withstand the test of time and scale to meet future demands.
So what does all of this mean for you, the listener? Why should you care about asynchronous messaging?
Well, for one, it's the driving force behind many of the applications and services you use every day, from social media platforms and e-commerce websites to online banking and streaming services.
It's the invisible hand that enables these systems to handle massive amounts of data traffic and user interactions without breaking a sweat, providing you with a seamless and responsive experience.
But beyond that understanding, asynchronous messaging can also give you a deeper appreciation for the complexity and ingenuity behind the software that shapes our world.
It's a glimpse into the minds of the developers who are constantly pushing the boundaries of what's possible, creating systems that are more resilient, scalable, and responsive to meet the ever-increasing demands of our digital lives.
So now that you've had this taste of the power and the challenges of asynchronous messaging, I want to leave you with a thought-provoking question.
How could this approach be applied to solve problems in your own field or area of interest?
Could you benefit from decoupling systems, improving responsiveness, or handling data more efficiently? Could asynchronous messaging be the key to unlocking new possibilities and creating more robust and scalable solutions in ways you never imagined? It's a question worth pondering.
Until next time, keep exploring, keep learning, and keep diving deep into the fascinating world of technology.
So these frameworks and libraries, they're like having that toolbox, right? Like all those specialized gadgets, and power tools that can handle, any asynchronous challenge.
That's a great way to think about it. Yeah, they really simplify a lot of the common tasks, like message serialization and routing error handling, all that stuff.
So it's like, instead of having to build everything from scratch,
Right.
you've got these pre-built components that you can just plug in and use.
Yeah, and that can save you a lot of time and effort, and it can also help to make sure that your systems are more reliable and robust.
Right, because you're not reinventing the wheel every time.
Yes, sir.
You're using something that's been tried and tested and proven to work.
Right.
Okay, so we've covered a lot of ground today. Can we take a moment to recap the key takeaways from our deep dive into asynchronous messaging? What are the essential things listeners should remember?
Yeah, absolutely. So I think the first key takeaway is that asynchronous messaging is a powerful paradigm for building modern software systems, but it does require a shift in mindset.
Right, we talked about that letting go of control.
Yeah, you have to let go of the need for immediate responses and embrace the idea of events and reactions.
It's about trusting that the message will get where it needs to go eventually.
Exactly, and it's about designing your systems to be resilient to the fact that things might happen out of order.
Okay, so that's the mindset shift. What about the technical side of things? What are some of the key technical takeaways?
Well, we talked about the importance of using tools like correlation IDs and structured logging to track messages and make sure that they're processed correctly.
Right. It's all about having visibility into what's happening in the system.
Exactly. And we also talked about the need to be aware of performance considerations and to design your systems to minimize overhead.
Right, because asynchronous messaging isn't a free lunch. It comes with some costs.
Exactly. And then finally, we discussed some of the challenges of working with databases in an asynchronous world and some of the techniques that you can use to overcome those challenges.
Right, things like data partitioning and event sourcing and read replicas.
Exactly.
So it's a lot to think about.
It is, but it's also very exciting.
Yeah, it is. It's a really fascinating area of software development, and it's only going to become more important in the future.
I agree.
So I want to thank you for joining us today on the deep dive and for sharing your expertise on asynchronous messaging.
It's been my pleasure.
And to our listeners, thank you for tuning in and for diving deep with us into this complex but important topic.
We hope you found it informative and engaging and that you'll come back for more deep dives in the future.
Until next time, keep exploring, keep learning, and keep diving deep into the fascinating world of technology.
See you next time.